As anticipated previously, in this lesson, we will use the Series A and prices per category objects to apply our indexing knowledge to practice. The code we've prepared and provided here will hopefully help you develop a better understanding of how the different types of indexing work. That said, please execute the selected cell to create the two objects. Once that's done, we'll have to check the contents of Series A. The output we received is the 5 integer values and implicit zero-based indexing. Great! Now, we can use some well-known Python syntax to indicate the value of interest. More precisely, we will add a 0 in brackets at the end to obtain the value that is an index position of 0. As we run this cell, we obtain the value from the first row of the series, which is 10. Let's keep an eye on the contents of prices per category. Here, we have an explicit index. Therefore, if we specify the string product A in brackets and then run the cell, we will obtain the corresponding price of $22,250. Furthermore, Python has implicitly provided a default integer index to prices per category. So, as we specify the index position of 0 in brackets, we obtain the same value, $22,250. For the same reason, we can use the index position of 1 to obtain the price for products B, and the index position of 2 for product C, respectively. Nice! There are 2 more scenarios to examine in order to complete the picture. First, let's create Series B so that it contains the same data as Series A. However, this time we'll assign an explicit index, a sequence of all integers from 1 to 5 in ascending order. Once ready, we can see what will happen when we refer to the value with an index position of 0. An error message appeared. How come? Well, Python treated the integers from 1 to 5 as index labels, and they were not interpreted as integer positions along the index. So, assigning integers as our series index is the only situation when we won't have an implicit numeric index additionally. If you think about it, it makes sense, as it would have been very confusing to be able to refer to a certain row from our dataset with different integers. This is another reason why, if we use the integer 1 within brackets in this situation, we will unequivocally obtain 10 as a result. The other situation we'll examine concerns the difference between using index positions and index labels when the latter are numbers written as strings. If this sounds unclear, don't worry. We will shed some light with the following example. Let's create the same identical series object, calling it Series C. This time, the integers from 1 to 5 written as strings will be our index labels. So, if we refer to the index value of 1 written as an integer, we'll obtain 20 because we'll be using the implicit Python index. On the other hand, if we choose 1 as a string within the brackets, we will obtain 10 because we'll be referring to the label-based indexing we specified during the creation of Series C. This means that in order to obtain 10 by referring to the implicit zero-based indexing, we should place 0 within the brackets here, right? Correct! As a matter of fact, the indexing used in Series C can become very confusing, so it is often avoided. Let's display the contents of prices per category to see a good example of label-based indexing, shall we? Very good. To conclude, access labels, also known as label-based indexing, can have several advantages and may serve different important purposes. First, by applying index labels, a non-numeric index, you can identify data by using indicators that bear intuitive names and are contextually related to the data forming a particular data set. This feature turns out to be extremely important for the next steps in your analysis, and particularly when you work on data visualization. Another important application is using index labels to explicitly refer to certain parts of your data. As an analyst working on a dataset, such as prices per category, you'll need to find a way to interpret the prices of different products, rather than try to remember which products are in, say, position 2 or 3 in your series. Of course, position-based indexing has its strong points as well. Imagine that you have a large dataset, and you want to retrieve the first 100 rows of data or examine the last 10 rows. In such situations, you will definitely refer to the positions of the elements in your series. You won't use the label. Okay, people, I think we did some great work in this lecture. As a key takeaway, please remember that you need to be careful when dealing with Python indexing. Yes, label-based and position-based indexing are two techniques that enable great analyses a bit later on. But it is our responsibility to handle this feature with caution while trying to apply it in practice. In our next lecture, we won't focus on metadata about Pandas series anymore. Instead, we will turn our attention to the practical things you can do with series objects. Thank you for watching.